Hi, this is Jeff Thomas. I first met Hamlin Jennings in 1989 when I went to Northwestern University to get a PhD in materials science. And as a new graduate student, I went around to all the professors to interview with them to try to figure out which group I should be in. Hamlin and I hit it off right away. I think we both liked each other right away, and he wanted me to be in his research group to work on cement. He was a new professor at that time. He didn't have a large group, and I really had no interest or intent to work on cement, so I considered it because I liked Hamlin, but I ended up going into a different research group. However, I worked on a material that Hamlin had worked on earlier in his career, and so he was my co-advisor, so we kept in touch. By the time I got my PhD in 1994, Hamlin had a very large and active group. He was getting a lot of publicity for his cement research, and so when he asked me at that time to come do a postdoc with him and start working on cement, I agreed. And we worked very closely together from that point up until 2010, writing papers together, collaborating together, long meetings in his office. He was my mentor during those formative years of my academic career, and we were good friends. During the period of the mid-1990s when I joined his group, Hamlin had no problem getting research funding. He was quite successful getting funding through traditional sources like NSF and DOE. He had some industrial funding as well. And more interestingly, he had private funding from a very wealthy man from the Middle East that he met while he was traveling. This man had a strong interest in cement and concrete and green technologies for infrastructure, and he and Hamlin met, liked each other, and this man started giving Hamlin private funding through his position at Northwestern. So Hamlin was able to build up quite a large group of several graduate students, postdocs. He had a couple of technicians as well, which was unusual in Northwestern. I think his group was as large as 25 people around the time that I joined. So it was really a very interesting and vibrant atmosphere. Hamlin would have large get-togethers at his big, beautiful house in Wilmette, just a few blocks from the Northwestern campus, dinner parties for the whole group. And we would sit around until the wee hours of the morning, talking and drinking, often outside around a fire pit. And Hamlin would encourage us to work on the big problems and try to make the big discoveries and not to just try to do small incremental papers. He was very ambitious. He clearly wanted to make a big impact on cement research, and he genuinely felt that cement research was extremely important. He loved to quote the statistic that concrete is the world's most used man-made material, and point out that there are still very many important things about it that we still don't know, and he really wanted to have his research group be a leader in discovering those unknown things during that time period.
Hi, my name is David Lange. I'm currently on the faculty at the University of Illinois, and I received my PhD from Northwestern University. And I'm also proud to say I'm Hamlin Jennings' first graduate student. I arrived back at Northwestern in '87. Hamlin Jennings, I believe, arrived that same year, and we met very early on and established a great rapport. And it was a very exciting time because this was when ACBM was just getting started, so we were kind of inspired by this new mission to explore cement science in a very different way. So what I remember most about those early days is that Hamlin had a great influence on me in trying to instill a sense of creativity and exploration, thinking out of the box, not doing the ordinary. And one of the things we did was get to use some pretty interesting new equipment. We were the first installation of an electroscan environmental scanning electron microscope on a campus. I think we had serial number 2. There were no user manuals. I remember that. We were always learning by the technicians that would come to service the equipment. We'd had training sessions, and everything was hand taught. So in those early days, I remember Hamlin and I had some very interesting experiences trying to make this thing work right. And we had some simple experiments that were kind of exhilarating because of the new things it could do. For example, we had a pack of silica fume particles that we could sever and create a fracture of the material by just reducing the humidity of the chamber, and then turning up the humidity, restore the crack, bringing all the particles back together. Kind of do this on command, this open close kind of phenomenon just by controlling humidity. You could never do that with a regular SEM, and so it was kind of exciting to see the potential of adding humidity to these experiments. Hamlin always had a lot of excitement. He was at his best when the ideas were new and crazy and out of the box. And so I think what I'll always remember is that he was very true to the academic calling to create new knowledge. He was excited about exploring new ideas simply to find out something new and different, never be conventional. That's what I remember most about Hamlin.
Hi, my name is Tate Coverdale. I'm the Director of Development for BASF Construction Chemicals in the Americas region. I met Hamlin first in 1989 when I became a graduate student at Northwestern University, and ended up working for Hamlin until 1993 as his graduate student. And I always look back on those times with great fondness, and not only that, but for the last 22 years since I've been in the construction and concrete industry, as a result of working with Hamlin, I've had a great chance to stay in touch with Hamlin and be connected to him. I was drawn to his energy, to his excitement for the field of cement-based materials. It was hard to spend any time with Hamlin and not get that, have that rub off on you. And not only was he excited about the field and contagious about that, but also just about doing good science in general. And the other really wonderful thing about Hamlin was he was very personable and treated us students as peers, and then that relationship continued on as after we graduated and went on into our careers. So I'm very sad to hear about Hamlin's death, and glad that I could pay some tribute to him in this way, and will certainly miss him very much.
Hi, I'm Maria Juenger. I'm a professor of civil architectural and environmental engineering at the University of Texas at Austin, and I was a graduate student in Hamlin's lab from 1994 to 99. I was a graduate student in material science and engineering at Northwestern, and this was a great time, frankly, to be a graduate student of his. One of the reasons was when I started, there were 20 people in the lab. It was sitting room only, or I guess standing room only, inside the student offices. There were at least 20 of us, and there was just no space. So you could think of that as a disadvantage, but the reality was it was just a really dynamic and exciting place to work. Part of that was him, that he attracted so many energetic, smart, sharp people who really wanted to be challenged, and he inspired them to do really good work. But so part of my favorite experiences, frankly, are the other students, and the interactions I had with them formed a huge part of my graduate experience. So when I started, I was on a fellowship, and I didn't have any sort of prescribed project to work on. And so most of the first year that I was at the lab, I shadowed other students, spent time with them, learned what they were doing, and had weekly meetings with Hamlin to discuss project ideas. And in one of those meetings, he asked me, I would say one of the top 10 pivotal questions of my research career. And on the face of it, as I've been thinking about it, it's not really that interesting of a question, but the timing of it was what was so important to me, and coming from him, it was a really important question and a really important meeting. So the question he asked me, this is going to sound really anticlimactic, but the question he asked me was, are you an experimentalist or a theoretician? Okay. At that point in my life, I'd done a lot of research already. I was only 22, but I'd been in several labs, and everything I had done was experimental. But I never really thought about it. I thought that's what research was, so that's what I did. But he asked me that question, and I thought about it, and I said, I'm a theoretician. I have no idea why I answered that way, no idea. But I think it was wishful thinking. Maybe I was inspired by the ideas that other people were working on around me, but I decided I was going to be a theoretician. Completely backfired. I'm such an experimentalist. Every way I live my life is experimental. I have no interest in theoretical work, and it became really apparent as I sat in on some meetings on developing phase diagrams for the cement system, and I just was so bored I fell asleep. Almost. Not quite. Almost. So I realized, but that question had me thinking. There are so many different ways to do research, and so many of those different ways were taking place in the lab where we were. So we had students like Chris Neubauer working on deformation mapping using environmental scanning electron microscopy. We had students like Ming Yang and Aaron Sake working on rheology of systems. And we had Paul Tennis working with Hamlin directly on CSH modeling. So we had so many different activities going on, and a lot of that was due to him. He was really both a theoretician and an experimentalist, and that's a really unique aspect in a researcher. To be able to have both skills is really unique and really important, and I think that's really, in addition to his personality, which was always inspiring, enthusiastic, energetic, his capacity to answer questions on so many different levels really made his work have significant impact and really inspired the students around him. And I think that's one of the very special things about him that I learned and really enjoyed participating in when I was a student. Thanks.
Before Hamlin came to Northwestern University, he worked at NIST, the National Institute of Standards and Technology, between 1982 and 1987. While he was at NIST, he was working on cement. In particular, he was becoming very interested in the kinetics of cement hydration and how the chemical reactions and the deposition of hydration product around the cement grains translated into the development of properties. In particular, he was trying to do something very esoteric at the time, which sounds very natural to us now, which was to develop a computer model of cement hydration. And that was something that nobody had done before. At that time, computers were very much less powerful and capable than they are now. So Hamlin was working on this pretty esoteric topic. The problem was that his boss at the time at NIST, who I won't mention in this video, disagreed with that and felt that Hamlin should be working on more practical things. And so they had this disagreement, and Hamlin, being Hamlin, just went ahead and did what he wanted to do, which was to work on this model and work on these really basic things. So Hamlin was finally making progress on this computer model, but in the meantime, his job was in jeopardy because of this disagreement, and Hamlin realized that he was actually likely to be fired because of this disagreement on what he should be working on. So he published a paper describing this computer model with his colleague Stephen Johnson in 1985. And colleagues of Hamlin, both at NIST and elsewhere, who realized that Hamlin was likely to be fired, felt that was very unfair and that Hamlin was doing great work. And so what they did is they actually started the Best Paper Award at the Cements Division of the American Ceramics Society, who I'm addressing right now. And so that paper won the very first Best Paper Award, which is now known as the Brunauer Award. And what happened then is it became very politically difficult to fire Hamlin from NIST just after he had won this very nice inaugural award. And so that actually bought Hamlin some time, and he was able to see the writing on the wall and look for a job, and he was able to land a very nice faculty position at Northwestern University that he started in 1987. But what's nice about this story, I think, is that that paper was very deserving of the award because it was extremely influential. Today, there are very many computer models of cement hydration. It's a whole field of using computer models of hydration and how the properties develop, and all those models are essentially predicated on that early model developed by Hamlin Jennings and Stephen Johnson and published in 1985. So the work that Hamlin is best known for today, and his most widely cited work, is his colloid model of CSH. And so thought it might be interesting to provide just a little insight on the process by which he developed that model. In the mid to late 1990s, Hamlin became very interested in the nanostructure of CSH and what was really going on inside the CSH. In particular, he became fascinated, you might say obsessed, with understanding the gas sorption data that would come from measuring cement paste, either with water vapor or with nitrogen. And this had been something where there had been much work done in the 1950s, 60s, and 70s. And Hamlin spent a lot of time carefully poring through that early literature from people like T.C. Powers and Rolf Feldman and other authors, Feldman and Serrata model. And a lot of that data really seemed just very confusing and didn't agree with each other. But Hamlin felt that there was something going on in there that could explain it, and he really just pored over that. You could just see him in his office with stacks of these photocopied reprints on his desk and on his floor and on his table, studying this for hours and hours. In 1994, he published a model which was sort of known as the Jennings-Tennis model, along with his graduate student Paul Tennis. This was not really a microstructure model, but it did hypothesize why you would get the results that you do with nitrogen absorption. And it made a very important hypothesis that there were two types of CSH, one type where nitrogen could penetrate and see the whole surface area, and another type where it could not. And that was new and controversial at that time. And so that model was an important step along the way. But he continued to work and think about the microstructure. And in the late 1990s, he and myself and Andrew Allen started publishing small angle neutron scattering papers on cement and measuring the surface area that way. And that provided a lot of additional data and insights that he started incorporating into his thinking. And so finally, in 2000, he finally submitted and published his initial paper on the colloid model, which was titled just a model for the microstructure of calcium silicate hydrate in cement paste. And I think probably everybody in this room has heard of that paper and has seen the sort of iconic figures from that paper with the little perfect circles that are clustered into different groups, and then the dashed lines that separate out what's the high density and what's the low density. It was too simplistic. Hamlin always knew that it was a little too simplistic, those perfect little circles, but it was a neat graphic way to describe what was happening, and people could understand it. You could look at that and you could understand that, which was a big advantage. And so the model became very well known. People used it, and the basic concepts of that model have held up pretty well since 2000, although Hamlin has, of course, continued to refine it and improve it and think about what's going on inside those little circles. They're not little circles anymore. But I think that model is probably what Hamlin is going to be best remembered for from his career.
So hi there. So for those who don't know me, I'm Karen Scrivener, Professor of Construction Materials at EPFL in Switzerland. So I first met Hamlin in 1979 when I went to Imperial College for an interview for a PhD position. And at the time I was thinking of doing something kind of classic like working on silicon nitride, but it was Hamlin who really convinced me that they just started work on this very interesting subject of cement hydration. And as they say, the rest is history. And really that's my abiding memory of Hamlin, his great and continued enthusiasm for the subject, which I think convinced many of us to come into the field and hopefully make some useful contribution to it. So I know he was always up for a good discussion, preferably over a glass of beer, and for that he'll be sorely missed. It's very hard for me to think that less than a year ago he was sitting on this very terrace at our house after a PhD exam, and seemed in very good health. So thanks for the start, Hamlin, and we'll miss you very much.
My name is Ellis Gartner. I'm Scientific Director for Chemistry at the Lafarge-Holcim R&D Centre near Lyon in France. But I haven't been in France all my life, as you can probably tell. And I want to tell you basically my recollections of Hamlin Jennings. Now, I was working in the US. I'm British originally, but I was working in the US from 1977 onwards at the Portland Cement Association R&D labs near Chicago, in the suburb of Chicago. And I can't remember exactly what year I first met Hamlin, but he was active in cement research at about that, started to get active about that time, because I know he was at Imperial College with Peter Pratt as a postdoc, I believe. And I must have met him surely at conferences, but I can't give the exact date of when I first met him. And so what I was going to say was that I think that it would be in the early 1980s when he moved to NIST, to Jeff Fronsdorf group at NIST there, when I had a better chance of meeting him on a regular basis. But one thing I do know is that we always got on well, and we always had a great time talking about the subject which we were all passionate about at that time, you know, cement hydration and cement materials science. Definitely we would have met at the Engineering Foundation Conference, of which there were several from 1979 onwards, every 3 years. I don't think I attended the one in 1985, but in 1985 I moved from Chicago to the Washington, D.C. area, in the Maryland effectively, to work for W.R. Grace, who had a corporate research center there. And at the same time, Hamlin was working at the National Bureau of Standards in Gaithersburg in Jeff Fronsdorf group. I think he'd been there a few years, and so we overlapped in the DC area, in the DC suburbs, and we got together socially. And I'm trying to remember exactly how this came about, but I think he showed me at that time the paper he was about to publish in the Ceramic Society journal, the famous paper which showed essentially the two solubility curves for CSH. What he'd done is he'd done an analysis of all the data in the literature on the solubility of calcium silicate hydrates, and found that essentially you had two separate curves. I can't remember now, it was curve A and curve B originally, I think it was. And so he presented this and with some tentative explanations for why there should be two different solubility curves. So we got discussing this. And I had some thoughts about how we might try to model this thermodynamically. So we worked on this together, or mostly communicating by email, I think, or equivalent at the time. I think we had email in those days. It's not that far ago. Anyway, we communicated about this, and in the end we wrote a joint paper on that, which appeared in the Ceramic Society journal in 1987, I think. So it was a year after the first paper. And we nearly got the Brunauer Award for that paper as well, because Hamlin was quoted. He'd already had one Brunauer Award, and he wanted to have another one. I hadn't had one, so that's why. And anyway, at that time, he moved then, strangely enough, back to where I had just come from, which was Chicago, the Chicago suburbs. He moved to work at Northwestern University, which is just a few miles away from where I had previously been working up to 1985. In the PCA, what used to be called the PCA R&D labs. So it was a bit of a coincidence, but after that, well, obviously I didn't see him very often, but we used to meet at conferences. I would sometimes come to Chicago and so on. So we kept in touch, and we always had a very good relationship, because Hamlin was the kind of guy that you could just talk about cement science, and he didn't take a strong hardline position that he was right and you were wrong. And he was a person that was really easy to work with and have good discussions with. Obviously, it was always better in the evening over a pint of beer, or nowadays we'd say a half litre, maybe just a litre of beer. But anyway, he was the kind of person, that you could always chat to, and I think he must have been a great PhD supervisor. Certainly, judging by the standards of his PhD students who are all active now in the field. He must have been an excellent PhD supervisor. So those are my initial recollections of Hamlin, and I will miss him a lot. That's all I can say. Somebody I was still talking to on a regular basis.
I'm George Scherer from Princeton University. I came to Princeton about 20 years ago after a career in industrial research in glass and ceramics, so I knew absolutely nothing about cement. And at one of the first cement science meetings I went to, I had the great good fortune to run into Hamlin Jennings. I took a long walk in the woods with Hamlin and Hal Taylor and peppered them with remarkably ignorant questions about cement. And they patiently answered all my questions and began a long period of consultation and education by those guys of me that lasted until we lost each of those great men. I couldn't have found a more patient and knowledgeable and open-minded teacher than Hamlin, and I'm going to miss him. Hamlin and I were at a conference in some lovely town in western France, and he was complaining that he'd just bought a pair of new shoes that were killing his feet. And that meant, of course, that we had to stop about every 30 yards at another cafe to have a beer and ease his sore feet. I don't know where we were going, but I'm quite sure we never got there.
My name is Ed Garbosi, and I am at the National Institute of Standards and Technology. Hamlin Jennings was the person who got me into concrete material science. In 1986, I was at Armstrong World Industries, working to develop a macro defect-free version of our phosphate cement. We came down to NIST in Maryland to meet and talk to Hamlin. I invited him to come to Armstrong for a seminar. After he moved to Northwestern in 1987, he visited me at Armstrong. His seminar went so well that there was talk of hiring him as a consultant. At the end of the visit, however, I told him that I could not be the primary contact for him at Armstrong. I was looking for another job, one with more research opportunities. He took it upon himself to call NIST, but they were still trying to find somebody to replace him, and recommended me. Then he called me back and told me that if I would call Jim Clifton at NIST, I would get an interview if I asked for one. I thought about it for a while. The details of Portland cement and concrete were new to me, even though I did know something about random porous materials. I decided to call Jim Clifton, and ended up starting at NIST in 1988. I have been with NIST ever since, and I moved to the Boulder, Colorado campus in 2014. One of the first things I did at NIST, along with Dale Bentz, was to be inspired by Hamlin's 3D cement paste microstructure model. We got started on developing digital cement paste models that would predict properties as well as microstructure. These models then led to mortar and concrete models and so on. I looked at my CV today and counted 12 papers that I published with Hamlin Jennings. They were all about connecting cement paste, cement chemistry and microstructure to the properties of cement and concrete. Hamlin certainly had a great influence on my career and a great influence on the whole field of concrete material science. We'll all miss him.
In 2010, Hamlin left Northwestern University and went to MIT. And that was a move that took a lot of people by surprise because at that point, Hamlin was a full tenured professor at Northwestern. He'd been there for a couple of decades. He was in his early 60s. He had a worldwide reputation. There was really no need for him to take on a new job. He and his wife Glennis loved the Chicago area very much. They had spent years fixing up their big house in Wilmette, and they had it just the way they liked it. And their daughter loved the Chicago area as well. So in some ways it was a very difficult decision, but there are some reasons for it. In particular, Hamlin was finding it increasingly difficult to get research funding to do the kind of basic research on cement that he felt was so important. So that was just the atmosphere, at least in the United States at that time, that despite all of the stories that you would read in the media about our crumbling infrastructure, it was actually pretty difficult to get funding, and certainly not at the level that he had been getting funding 10 years before. So his research group had shrunk down to just a couple of graduate students at a time. Both of us were struggling to get money to buy any equipment or even to keep our equipment running, and so it was a time when we were doing good research, but at the same time it was frustrating to not have any money to really support it. So when he got an offer to become the first executive director of the CSH Hub consortium at MIT to do research on cement, that was really just too much of an opportunity for him for him to resist. And so he moved to Boston, to MIT, and to become this executive director. He found that the executive directing part of the job was pretty difficult, and I don't think he enjoyed that very much. But on the other hand, he just loved the intellectual atmosphere at MIT. In particular, he became a mentor to many graduate students and postdocs who were in the CSH hub working on basic cement research, doing all sorts of molecular modeling and advanced experimental methods. He kept his office door open, and these students and postdocs would come by and talk to him all the time. And I know that some of these graduate students spent more time talking to Hamlin than they did to their own research, own thesis advisors. And so it was really a good move for Hamlin in that respect, that it really put him back into the kind of what he felt was the center of everything in terms of cement research, and he really loved that. The most recent paper that Hamlin published came out in June of 2015, just about 1 week before Hamlin died. This paper was published in Phys Rev Applied, a very nice journal, and this paper actually provides a good example of how Hamlin operated at MIT in the kind of vibrant intellectual atmosphere that there was in the CSH hub at MIT. This paper came out of a draft that Hamlin and I had written in 2010. And then in 2010, he moved to MIT. I actually moved from Northwestern to the Boston area myself to take a job at Schlumberger. And so the draft lay forgotten for a couple of years. And that's probably a good thing, because although the draft had some nice ideas about the movement of water in and out of the small spaces in CSH and how that explained the hysteresis in drying and rewetting curves, there weren't any new data in the paper, and there wasn't any proof of the kind of things that we were hypothesizing. So frankly, it wasn't a great draft. It was just had some good ideas. Hamlin resurrected that draft a couple of years later, maybe in 2012, and he started showing it to people and talking to people at MIT and getting them interested in it. And so sort of one by one, he had this growing group of people who were working on modeling the movement of water in and out of the smallest spaces of the CSH in different ways, and he would have these weekly meetings which got larger and larger, and they started really delving into what was going on with molecular modeling, and until finally, even when Hamlin was very ill and it was difficult for him to work, he was shepherding this paper through the review process, through the editing process, until it came out. And when the paper was published, it had 10 co-authors. In addition to Hamlin and myself, there were 3 full MIT professors from 3 different departments who were authors on the paper, and there were 4 former graduate students and postdocs from the CSH hub who held positions now, good academic positions, in Japan, in England, in France, and also in China. And so I think that when you look at all the people who were co-authors on these papers, people that Hamlin interacted with while he was at MIT and who are now starting academic careers around the world, I think you can see the influence that Hamlin's going to continue to have on cement research for many years to come. And I think that's going to be a really good legacy of Hamlin Jennings' career.
I'm Jeff Chen. I'm a researcher at Lafarge Holcim R&D, and Hamlin was my PhD advisor at Northwestern. This was after the golden years of Northwestern, so between '98 and 2003, and those were some pretty good years for me. Not only did I get a chance to establish myself as a researcher in the cement field, but on a personal level, I think this period was a time where I really started to grow and gain confidence in creative and independent thinking, and Hamlin had a lot to do with that. You know, he was the ultimate optimist. You know, you go into his office with a question or a new idea, and he'd basically drop what he's doing and start to engage with you in a really exciting conversation. And I love that about him. You know, in the end, you always walk out of his office with basically a mission to prove or disprove your idea. And it was great to have that push. It was great to have that coach behind you during the PhD. And ultimately, I came out as a stronger person out of that. So I really had to thank Hamlin for that. And the second thing I'd like to share is really the experience I had with Hamlin during the past few weeks. So Maria Juenger and I, which we were calling, or tried to call Hamlin, get in touch with him to see if he needed any help in his De La Roy lecture. And it was tough. I mean, understandably, he was focused on getting healthy. He was doing therapy, so we had a difficult time to connect with him. But I did manage to talk with him for about 2 or 3 minutes on Skype. And it was great to hear his voice. I hadn't heard from him in a few years. So his voice sounded pretty strong to me. And I even told the executive committee in this sense that I was pretty hopeful that he might come to Kansas. So unfortunately, it didn't happen. And Maria and I never got a chance to really work with him to prepare his lecture. So we're pretty sad about that. But he said 2 words to me that's sticking with me now. Basically, he said, keep trying. And he sent me an email with the same message, keep trying. And what he meant by that was, keep trying, keep bugging him so that his De La Roy lecture would be in good shape for this conference. And, in retrospect, those words, keep trying, it was the perfect way to say goodbye. It really captured the essence of Hamlin's optimism, his open-mindedness that had a profound impact on me, as well as many others who came in contact with him. So Hamlin, I'm going to miss you a lot. And I think what I'll remember you most by is that simple and beautiful idea of keep trying.